Recording again? Yeah. And okay, I'm gonna go ahead and share this pane again. All right, so we're gonna go over the last the first of the last questions we talked about. All right. So one dive is going to an average of 58 and it lasted 58 foot and it lasted 46 minutes on an aluminum 80. All right, so the first and then the second dive was an average of 116 at 27 minutes on a steel 100. And then determine the RMV, that's respiratory minute volume for each dive, and say which one was better on air. All right, so we'll just split it right down the middle, and we'll do the aluminum 81 over here, 80, and we'll do the steel 101 over here. All right, so the first thing you don't normally like to do is to figure out what your thumb rule is for cubic feet per PSI. All right, so I like to do 80 cubic feet. Is 3,000 PSI. Therefore, I pull up a nice little calculator. I go 80 divided by 3,000. Whoops. 3,000 equals 0.027. And then that repeats itself. Okay. That's this is pounds. Don't forget units. That's important. Pounds. So cubic foot per pound. And that's like our magic conversion factor. Okay. And that's on the surface, remember. And then same thing over here. It's 100. Bad 100 cubic foot divided by 3, 4, 4, 2. Right? We use 3, 4, 4, 2 because that's the design pressure for the cylinder at 100 cubic feet. Just remember that because we'll use a different value later. Okay, so again, here you do value of clear button 3,442 divided by oops. Oh, I can do it still 100. I did it the wrong way, so I'm going to invert it. My invert button right there. There you go. You guys see how I did that? I made a mistake and I did this one on top of that one on the bottom. And after I did the math, I just pushed the invert button. It just flips it back and forth. But I'll do it the right way. So you can go 100 divided by 3,442. That's the right number. If I did the wrong way, I could just invert it. And it's the same thing. That's what that button means. Cool little trick I found out along the way. So that was a 0.029. That doesn't seem like that big of a deal, but it actually turns out to be a big deal when you're doing these calculations. Okay, and this is again cubic feet per pound. All right, so now you know how many cubic feet per 1 pound is. And now we can start doing some more calculations here. All right, so next thing you're going to figure out, we're going to make some presumptions. Down here it says share your presumptions down here. Okay, and we're going to say an average depth of 58 feet for 46 minutes. Okay, so we're at 58 feet for 46 minutes. So what is the unit we're trying to get to for RMV? Anybody? It's asking me for what my RMV is. So what's the unit I need for an RMV, respiratory minute volume?
Time.
Well, you need time. Yep. It's something per minute. It's going to be in PSI.
So pounds per minute.
Pounds per minute. Right. So I have feet per minute in depth. Right. But I need to get to cubic feet per pound. So how do I make this transition here? Well, I have 27 minutes. Well, that's pretty easy. That'll calculate that out. How do I do the rest? I'm trying to remember here too. It's been a while since I've done this. Let's take a look here. Let's think about it for a minute. All right, we got to figure out how many atmospheres this is at, right?
Yeah.
Not yet. That's at the end. That's when we're trying to figure out where SAC rate is. So 54 feet, 46 minutes on aluminum 80. Right, so it's a cubic feet per minute, and it's 58 feet for 46 minutes. All right, so we are burning through versus a steel. This is okay. Yeah, here we go. So we're presuming that it's a 3,000 pounds is our starting point. That's what I was forgetting. And our ending point is how much? 500 PSI. Right?
500.
Yeah, 500. Presuming that we're good divers and we end our dive with 500 pounds. Okay. And then our it's minutes. It's this number of pounds per minute. So it's 2,500 pounds. 2,500 pounds. 500 pounds over 46 minutes. Okay. And then you have the point. Oh, and then you had that over. Okay, so that gives you pounds per minute. So we do the 2,500 pounds. 2,500 pounds by 46 minutes. That gives me 54 pounds per minute. 54 PSI per minute. And that is my RMV. Okay.
Got it.
That's respiratory minute volume. Well, that's not really a volume. You would have to you have to change that back to uh, cubic feet, but it doesn't really give you any value unless you're on rebreathers, right? So it's actually respiratory minute pressure, but it doesn't really matter. If you wanted to know what the volume was, you just have to do some math here and then use this here and then just revert it back to cubic feet, right? But that's not going to do us much any good because we're going to take it to the surface and then we'll use this to go back to cubic feet per minute, right? So now this is at how many atmospheres? This is at depth, right? So this is at 58 feet. So we got to figure out how many atmospheres that is, right? So depth in atmospheres equals your depth in feet divided by 33 plus 1. Everybody remember that?
Yeah, I think I can.
Simple ratio, right? It's every 33 feet is 1 atmosphere, right? And then you have to add 1 for the air on top of you. Remember that?
33 feet is technically 2 atmospheres.
Say again?
33 feet is 2 atmospheres.
Right. So if you did 33 feet, that's 1 atmosphere of water, and then you have to do 1 atmosphere of air.
Okay.
Makes sense?
Uh-huh.
You always have to add 1 for the air, right? So we do 58 divided by 33. And that's 1.75 atmospheres. Okay, so if you're going to make this bigger or smaller as you step into the surface, is this number going to go up or down?
Okay.
It's going to go down, right? It's going to get better, right? So from here, we're going to divide it. So it's going to be 54. Do this over here. 54 PSI per minute divided by 1.75. 54 divided by 1.75 equals 30.8. 30.85 PSI per minute for this particular cylinder. Okay, but if it's this particular cylinder, that's cool. If I use that particular cylinder every time, but that doesn't really help me. So I have to convert that to cubic feet per minute. And I do that by multiplying it by this little gem right here. By doing, we do 3,000 pounds PSI, whatever, is 80 cubic feet. Sorry, that's about 80. That's about cubic feet. Right, so you just multiply 30 times 80. 30 times 80 equals, and then you divide that by 3,000. That gives you, whoops, 2,400 divided by 3,000. That gives you a 0.8 cubic feet per minute on the surface. That's your SAC rate.
Oh,
easy, right?
So that, no, extremely complicated.
All right, we'll do it again over here.
Yeah, but so where did we get the? I'm trying to get so I can see it a little bit bigger. So I'm on my cell phone right now because I couldn't get the Zoom chat update, which took forever.
Okay.
So the 80 cubic feet over 3,000 in the top, which equaled 70.027 cubic feet.
No, sorry. This is 0.027. That was a therefore sign.
Okay. So so that 0.027 cubic feet, that's at the surface, right?
Yes.
And then the other one, I'm confused.
What are you confused about?
I'll watch you do it again. Let's see.
Okay, we'll walk it through on this one. Hey, I'm in the middle of a class. Okay? I love you. Go see mama. Go see mama. I love you. Okay, you got my phone. Here you go. Okay, we'll do it again over here on this one. We already got the pressure to cubic feet conversion over here. It's just the number of pounds divided by the number of cubic feet divided by the working pressure for that number of that volume for that particular cylinder. Does that make sense? So this is a steel 100, and the working pressure for a steel 100 is 3,442. Okay? Everyone checking on following that one?
Got it.
Okay. So the first thing we're going to do is we're going to assume you can't really read 3,442 on an analog gauge. So we're going to assume you read it as 3,500. Okay, does that make sense?
Mm-hmm.
Are you in the waiting room again, Pachenko?
Yeah.
Okay. Oh my God, echoes. So that's our starting pressure.
It's not letting me exit.
That is our ending pressure. All right, and then we get our time elapsed is 27 minutes. Therefore, it's 3,000 pounds. Over 27 minutes. Bring this guy up. 3,000 divided by 27 minutes. And that's 111 pounds per minute. That means when you're breathing off of this cylinder at this depth, 116 feet, you are burning gas at 111 pounds per minute. That makes sense?
Copy.
Okay. So depending on your computer and stuff, some computers will give you an RMV. Other computers would take this into consideration and give you a SAC rate. So if the number stays the same all the time as you change depth, it gives you a SAC rate. If it changes as you change depth, it's giving you an RMV. Okay. Anyway. All right. So now we have the RMV, or its PSI equivalent. Like I said, if you dive the same cylinder every time, or the same size cylinder every time, RMV is just as good as your in pounds per minute as it is in cubic feet per minute, because it's the same amount of cubic feet per pound per square inch. But if you're going back and forth between different cylinders, this value is different. Right, the number of cubic feet per pound is different. So you have to convert back and forth from cubic feet to PSI, which complicates things. But if you're always diving steel hundreds, then it doesn't matter. You can convert. You can always just be like, okay, my RMV is, or my SAC rate's, 0.5 cubic feet per minute. As long as you're using the same cylinder, 0.5 is 0.5 is 0.5. But if you go to like a aluminum 63, 0.5 is not the same thing, right? As a 0.5 on this. Does that make sense?
Makes sense.
Okay. All right. So from here, next thing I got to do is figure out the number of atmospheres I'm at. Right. So I'm going to go my depth in atmospheres. Is going to be equal to 116. Get that from over here again. 116. So it's a bad 16. Okay. Feet. That's a good F. Look at that F. All right. Divided by 33, because that's a simple ratio of water depth. And then again, I add 1 for the air depth, for the air on top of the water. And I'm going to go ahead and clear that. 116 divided by 33. That's 3.5 atmospheres of water plus 1 atmosphere of air. That's 4.5 atmospheres.
Hmm. Okay.
Okay. So now I need, since remember I'm going up to the surface, so this number is going to get smaller because of Boyle's law. Okay. Just remember, like you can always remember, well, crap, do I have to divide that? Do I have to multiply that? Just think practically. If I'm reducing depth, that number is going to get smaller because Boyle's law, right? Because the air consumption rate goes down as you reduce depth. Intuitively, you guys know that because you're experienced divers. So I'm just going to do 111 divided by 4.5. And that's 24.6 pounds per minute on the surface. So over here, we're 54 point, what were we? No, we were 30.8 pounds per minute on the surface. Over here, we're 24.6 pounds per minute on the surface. Are those the same? Is this one better than this one? You don't know yet. You got to plug this guy in first and then find out, because these are not the same thing. This is apples versus oranges, because this is a steel 100 and this is an aluminum 80, right? So now to see the difference, I need to plug in 100 cubic feet divided by 3, 4, 4, 2. So I go 24.6 times 100. That's pretty easy. Divided by 3, 4, 4, 2 equals, what was that number? 0.710, 0.71. So you can see that this SAC rate, these are in cubic feet per minute, was slightly better than this one. Makes sense? Any questions on all that?
I got it.
Let me show something for demonstration real quick. Do that real quick. So say for instance, I had, what happened just now? All right. Do this, that, and then I'm gonna fill this in again. Okay, now let's say I had, let's use 30.8 again, PSI per minute, just for presentation's sake. I had 2 cylinders. I had aluminum 80, 30.8 PSI per minute. And I use the 0.027. Actually, no, I wanted the 80 cubic feet over 3,000. Okay, and then I have the same thing, and I use 100 cubic feet over 3, 4, 4, 2. And then I use the same thing. I say I use a aluminum 63. Those are rated to 3,000 pounds. Okay. Same pressure per minute rate, 3 different cylinders. And you can see that the SAC rate is going to be pretty different for all of these. So we already know what this one is. This one was 0.8. Oops. This one was 0.8. And these are all in cubic feet per minute.
Or do you want to show us your screen, or
you can't see it?
No, we just keep seeing your face pop up.
You haven't been able to see my screen the entire time?
No, we saw it most of the time up until you finished the last calculation on the steel.
Got it. All right, let me find the Google things here. I don't know why that disappeared. Okay, can you see it now?
Yes.
All right, so I have my 3 cylinders, cubic or 80, steel or aluminum 80, aluminum 63, and a steel 100. Again, this one was the same from over here. So that's the 0.8. This is in cubic feet per minute, which is the standard SAC rate units. Okay, then now we do the 30.8 times 100 equals divided by 3,442. If I had the same SAC rate for a steel 100, now it's 0.89. It's not an insignificant change. And then let's say I had the same thing for aluminum 63. 30.8 times 63 divided by 3,000. And that's 0.64 cubic feet per minute. All right, so you can see the same PSI per minute breathing on the different cylinders have different SAC rates. So what questions do you guys have on all this stuff?
None so far.
Really? Okay.
I'll come up with something later though, for sure.
Okay. We'll do the second question on the next hour. I got 5 minutes left. I'm going to log off, and then I'm going to log in under a different Zoom account. And I'll share that thing with you guys so I can record that one too. And then we'll go over Dalton's law.
So the second one's 0.89?
Yep.
Okay.
It's 30.8 times 100 divided by 3,442.
Yeah.
Do that one. I'll do that math again.
We need to get you a better whiteboard where you can type numbers into it.
It's really, really hard to do fractions and stuff. I used to have a pen. I used to have this cool, mouse pen. You can ask Terrell how awesome it was, but it stopped working.
Yeah. So with this though, you divided 80 by 3,000 and get the 0.8.
I multiplied 30 times 80, and then I divided the whole thing by 3,000.
Okay.
Same thing with this. I multiplied 30 times 100, multiplied the whole thing by 3,442, and then I did 30 times 63, and then divided by 3,000. Any other questions on the mathematical functions?
Yeah. I did what you just did. I drew the arrow so I'd remember. Okay. I did multiply first, divide second.
Doesn't matter which order you do it, you should get the same thing. You can divide this by this, then multiply by that. You can divide. You can divide this by this, and then multiply by that. It's all multiplication and division. You can smash it all together. It really doesn't matter. It does matter over here, though. But when this is mathematically the same as this, like the railroad track method and then the parenthetical method, it's the same thing. Any other questions on this? We got 2 minutes left on this one. Okay, so I'm going to go ahead and look at our last question that we had. Where is it? And it's in the chat group. Is it this one? Nope, that's not it. It's a video. I've got a minute left to find it, really. Okay, here it is. So this one is kind of a doozy. This is a combination of the 2 lessons ago and then this lesson, 1 lesson ago. So I'm going to go through this week's lesson, and then if there's time, I'll go back to this one. But it's all Boyle's Law.
Where can I get a copy of all these questions?
They're on the group chat. Oh, that's the improper use of your crap. Anyway, yeah, they're on the group chat. I can post it again. I'll share it to the top.
Okay.
All right, I'm gonna close this one out, and then I'll share another one with you under a different login. Okay. I'll be back in 5 minutes. 5 minute break.
July 25th. Yeah.